The next section we're talking about is it's a type of exponential and logarithm with a special kind of base. So this little e thing here and this ln has a special kind of base that we're just about to talk about. So here we go. So what is this e thing? Well, e is a constant. Okay, it's just like pi. It's some number that goes on for forever. It doesn't end. It's an irrational number. Okay, so it's just a number that's found in nature, just like pi is. So we have e equals about 2.72. I'm not going to make you guys memorize it or anything, but you do know it's about 2.7, just so you kind of know in your head what it is. Okay, so this will be the base of our exponentials and the base of our logarithms, which, when they have e as the base, they are called something different. So let's talk about this. So this is y equals e to the x. So in exponential form, it is still called e, but when it goes to a logarithm form, our logarithms are going to look a little different. So if we think about this, what is the inverse of e to the x? Okay, so we think about it when we convert from an exponential to a logarithm. Okay, the first thing we do when we find an inverse are an x and our y trade places. So if you can kind of visualize, the x would be where the y is, and the y will be where the x is. And then we'd have to convert to a logarithm. Okay, so basically we rearrange this into a logarithm, which we did this in class. It would be y equals log base e of x. Okay, that's what it would be if we converted this into a log like we've been doing. Okay, but we never see log base e of x written like that. This is what you will see when it's log base e. So if you guys see here, this is ln, which is natural log of x. Okay, we don't pronounce it ln, we pronounce it natural log. That's the proper way to say that. Okay, so if you ever see ln x or natural log x, the proper way to say it, secretly there's a base e hiding out. Okay, so these two mean the same thing. Okay, so we're going to be working with this. If this doesn't make any sense right now, it's okay because it'll make more sense once we start solving. So we're going to be solving using all the log and all the exponential properties that we talked about, but now with a log of base e or an exponential of base e. Okay, so the first thing, we're using the inverse property, which if you remember, if the bases of a log are the same, everything cancels out except the exponent, so you're left with an x. Or the reverse is true if you have an exponential raised to a logarithm. Since those are inverses and they have the same base, they cancel each other out, and you're left with the x. Okay, which we used this property a few sections back. If you don't remember it, you can go back and watch the Prezi video on when we did log properties. Okay, so in our next example problems that we're going to be doing pertain to when we are solving with the inverse property. Sorry. All right, so go ahead and pause this video and watch example problems 1, 2, 3, and 4. Okay, this will be the funsies we'll do later, so you guys have to wait on those. Okay, the next thing we're going to talk about is solving exponential and logarithm equations, but this time using base e. So you're going to see natural logs and you're going to see exponentials. And all the same rules apply when we solve with logarithms and exponentials. Okay, so all those rules we talked about before are going to still pertain. We're just going to have some e's in our answer. Okay, so don't forget when we have logs, remember anytime there's a variable in the log, you have to set those bad boys to be greater than 0. Okay, so these are actually not going to be examples 1, 2, 3, and 4. If you remember these were examples 1, 2, 3, and 4. So they're not properly labeled. So the next ones are going to be examples 5, 6, 7, and 8. So go ahead and pause the video and watch example problems 5, 6, 7, and 8. These are the funsies, which will be later on. Alright, and again, these are not properly labeled. This will now be example 9 and 10. But anyway, so now we're going to be solving using our inequality properties, which we already talked about when we did them in the last section. But now, we're just going to have some e's and some natural logs in our answer. Okay, so the same rules apply with our inequality. Don't forget, you have to look out for some lower bounds. So if you see that x is less than something pop up, you're probably going to have a lower bound. So you're going to have to watch out for that. Alright, so go ahead and pause the video and watch example problems 9 and 10. This is a funsy for later. And that's a wrap, you guys.